had some questions about instantaneous velocity, how to do some acceleration problems, and a variety of other help. So I'm hoping that this one problem will help clarify some of those questions that I got on the weekly survey. So let's start with a problem here. I have a car that's sitting at a stop sign, or it's a truck as I've drawn it in my picture. And when I do that, and if my problem tells me it's at a stop sign, I can actually assume what the initial velocity is. We're also told in the problem that after a distance of 10 meters, that we're going to have a final velocity of 10 meters per second. And then once we reach that final velocity of 10 meters per second, we're going to proceed down 50 meters for a time period of 5 seconds. So we know that the total distance, so some things that we already know, we know that the distance total for this situation is going to be 60 meters. So I can actually start calculating an average velocity when I know my total distance. But there's some other things that we want to look at. For example, we want to maybe make a position versus time plot. Well, I know that once I hit 10 meters per second, I'm going to travel for 5 seconds. But what I don't know is the time that it took to do this. So I've got a question there for this time. So that's one of the things I might want to have to find out. And I also don't know my acceleration for this one either. So it's probably something that I want to calculate the acceleration. So this gives me, I have an initial velocity, I have initial velocity, I have a final velocity, I know my distance, but I don't know time and I don't know my acceleration. So let's look at our toolkit. So I'm going to bring out our toolkit, and those are our 3 kinematic equations. And I can get some really good information here. If I want to solve for my acceleration, I've got distance, my initial velocities, and the only thing that I don't know in this case is acceleration. So let's go ahead and do that. So I'm going to rearrange my equation. I've got my final velocity squared minus my initial velocity squared divided by 2 times the distance is going to equal my acceleration. We know that my initial velocity, or my final velocity, is 10 meters per second. My initial velocity was 0 meters per second. And I'm going to be 2 times the distance, and my distance was 2 meters. And this is going to be squared. So my unit's on top. So when we're looking at that unit analysis, velocity is in meters per second. So now on top, I've got meters squared, seconds squared. On the bottom, I have meters. So my unit analysis says I'm going to have meters per second. So we've all, or second squared, sorry. I'm going to have meters per second squared. So I've already done that. I can do that calculation, and I get 100 divided by 20. So I'm going to end up with 5 meters per second squared. And so my answer for my acceleration is 5 meters per second squared. Now that's going to be an interesting thing when we look at our graph. So let's look at the time. All right, so I have another equation that I can look at. I know my final velocity. I know my initial velocity. I've calculated my acceleration, so I already know that. So I can solve for time. So let's do that. So I'm going to have my velocity final minus my velocity initial divided by my acceleration is going to give me time. I'm going to have 10 meters per second minus 0 meters per second. And my acceleration now is 5 meters per second squared. So let's do that unit analysis. So I've got meters per second divided by meters per second squared. And now my ultimate answer is going to be in seconds. And when I do that calculation, I got 10 divided by 5. So that's going to be 2 seconds. So we've got an interesting thing happening here. So I could actually do a position versus time plot. So if I do that position versus time plot, we know that at 2 seconds, I am at 10 meters. And then as we go from 2 seconds and we go to an additional 5 seconds, I'm going to go from that 10 to that 50 meters. I'm going to do an additional 50 meters. So I'm going to be ultimately at 60 meters. So I'm going to give myself a graph here. So let's look at our graph. And let's look at our graph here. And we know that that's going to be at our 7-second mark. So I'm going to, again, I'm plotting my graph so that I have this. And what the problem told us was we were traveling at a constant velocity. We were traveling at our 10 meters per second for that 50 meters. And so if I plot my graph here, I'm going to get a straight line on my position versus time plot. The straight line is going to tell me that I'm at a constant velocity. So the straight line tells me I'm at a constant velocity, and then I can look at an instantaneous velocity along this straight line. So let's think I'm in the car. I've set my car to cruise control. I'm at 10 meters per second. I'm on that cruise control. Anywhere along this line or the slope of this line, my instantaneous velocity is going to be 10 meters per second. So I'm going to get an instantaneous velocity is going to be the slope of this line, and I can actually look at that instantaneous velocity, and I'm actually looking at it as if I were on my speedometer. Well, that's not quite the same situation that I have in these first 2 seconds, because we know at 0, I was at position 0. So let's figure out what my distance is at 1 second. So we can use our third one here. And we know that if my initial velocity was 0, my distance is going to equal 1/2 the acceleration times time squared. So if I'm at 1 second, I'm going to plug in that value at 1 second. So I'm going to get 1/2 of my 5 meters per second squared. And I'm going to do my 1 second squared. I've got second squared, they cancel out. I get that unit analysis again, and I'm actually in meters. And so I'm going to be at 2.5 meters. Well, that's kind of interesting. So down here, I'm really going to have a point that looks like this. And we'll see this over and over again, but I'm actually going to have a curve here because I'm traveling at this curve here says I have an acceleration. And since we're in general physics, we are knowing that that is a constant acceleration. And we'll actually see that on my velocity versus time plot, because we're going to actually do that. So I've got the curve says there's an acceleration. And then if I want to get an instantaneous velocity, what I would do is that lovely mathematical trick, and I would look at the slope at a point tangent to that curve. Or I can look at my velocity versus time plot. So let's do that. Now here we know that after 2 seconds, okay, after 2 seconds, I'm going to go ahead and plot my plot here so that we can get that nice plot, because I'm not using graph paper, but I'm actually creating my own graph paper. And I have my 7 seconds material here. So I'm actually doing my velocity versus time plot. We said that we're at a constant acceleration. So at a constant acceleration, the slope of a velocity versus time plot is going to be a straight line. So a straight line on this type of plot tells me I have a constant acceleration. So again, the differences here is this is time in seconds, and this is position, which is in meters. This is time in seconds, and this is velocity, which is in meters per second, and I get a straight line gives me a constant acceleration. But then we know we're at a constant velocity through the 2 through 7. So I'm going to actually go ahead and plot this in here so we have our nice constant velocity. So this is a velocity versus time plot, or you might see this as a VT plot. This you might have it as an XT plot so that you can actually see those different plots. But now I can look at what's my instantaneous acceleration. Well, if I have a constant acceleration anywhere along this line, my instantaneous acceleration is going to be that 5 meters per second squared. But let's look at the instantaneous acceleration on this portion of the plot. I don't have an acceleration. My acceleration is equal to 0 because I'm traveling at a constant velocity. So there is no acceleration. If I have this kind of a line that says there's no acceleration, and so my instantaneous acceleration on this portion of the line is going to equal 0. So hopefully what you've seen in this particular problem is we've taken a problem. We've done two different parts of the problem because we were given two parts of the information. We looked at our toolkit and calculated some other information. We've looked at instantaneous velocity, my instantaneous velocity along this line, because a straight line says it's a constant velocity. I can calculate that instantaneous velocity, or I can look at the tangent to the curve to give me an instantaneous velocity. I can look at an instantaneous acceleration because I'm traveling at a constant acceleration along this curve. And we can look at the description of the motion depending on whether or not we're doing a position versus time plot or a velocity versus time plot. I'm hoping that helps address a couple of the questions that people had. And if there are more questions, please email me or ask in the weekly survey.